Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P04F0, relates to an issue within the Evaporative Emission (EVAP) system of the Honda Civic 2022 and newer models. This code indicates that the Powertrain Control Module, PCM, has detected an incorrect purge flow associated with the EVAP system. The purpose of the EVAP system is to prevent fuel vapors from escaping into the atmosphere, thereby reducing emissions and improving environmental safety. Components such as the EVAP canister, purge valve, and various tubes play vital roles in this system. They collectively allow fuel vapors from the fuel tank to be directed to the engine for combustion, instead of being released into the air. If the PCM identifies that the EVAP canister purge valve seems normal but detects irregularities, it will trigger this code as a warning. Understanding this DTC is crucial for effective troubleshooting and ensuring the vehicle operates efficiently within emission standards. The DTC P04F0 indicates a fault in the EVAP system related to the flow of purge gas. Key components affected include the Evaporative Emission Control System, EVAP, canister purge valve, located typically near the fuel tank. The EVAP canister, which is responsible for holding fuel vapors, and the purge tube, B and D, which facilitate the flow of fuel vapors to the engine. Additionally, the non-return valve, integrated with the EVAP canister purge valve, prevents backflow, ensuring that vapors are directed toward the combustion chamber efficiently. Each of these components plays a critical role. The purge valve allows vapor to enter the engine when conditions are appropriate, while the canister temporarily stores vapors to prevent them from entering the atmosphere directly. Their locations can generally be found along the fuel system, easily accessible for inspection and testing during diagnostics. Several potential causes could trigger DTC P04F0. A stuck or malfunctioning evaporative emission canister purge valve is a leading suspect, as it may fail to open or close correctly, leading to improper purge flow. Blockages in the purge lines, including purge tube B and D, might interfere with the vapor transfer, causing the PCM to recognize a flow issue. Additionally, faulty sensors, such as the fuel tank pressure (FTP) sensor, which monitors vapor pressure within the fuel tank, can also contribute to this fault. If any sensors provide incorrect readings, they can mislead the PCM into suspecting an incorrect purge flow. Regular inspections and maintenance of these components can help prevent such errors and ensure the system operates within specification. Symptoms associated with DTC P04F0 typically include the illumination of the check engine light, CEL, which is the vehicle's way of indicating a malfunction within the engine control system. If this code is triggered, you may also notice an increase in emissions, as the EVAP system is designed to capture vapors that might otherwise escape into the environment. Additionally, drivers may experience issues with engine performance, such as hesitation or rough idling, particularly under load. In some cases, there could be a decline in fuel efficiency, attributable to improper vapor management. While these symptoms can indicate various issues, if the DTC P04F0 is present, they should be investigated, focusing on the EVAP system's components and functionality. Begin the troubleshooting process for DTC P04F0 by turning the vehicle's ignition into the on mode without starting the engine. This allows access to the vehicle's diagnostic systems. Then, utilize the Honda Diagnostic System, HDS, to select the EVAP test and proceed with the function test. Performing this function test is critical, as it provides the technician with a preliminary overview of the EVAP system's operational status. The HDS will run a series of checks, analyzing the components involved in the evaporation system, and will help to identify any electrical or operational issues within the system. Adequate knowledge of the HDS functionality is essential for effective diagnostics and to ensure the test results are interpreted correctly. In the second step, carry out a thorough inspection of the evap canister purge valve. This component is crucial in regulating the flow of fuel vapors from the evap canister to the engine. One of the common failure modes is that the valve might become stuck, either in the open or closed position. You should visually inspect the valve and adjacent connections, looking for signs of damage, clogs, or items that may obstruct its operation. Verifying that the valve closes properly is imperative, as a stuck open valve can lead to excessive vapor release, negatively impacting emissions. If any issues are found during this inspection, replacing the purge valve may be necessary to restore proper function to the evap system. The third step involves inspecting Purge Tube B, which serves as a critical pathway for vapor flow from the evap canister purge valve to the engine. Begin by visually examining the tube for any visible signs of blockage, wear, or damage. Common issues related to this tube might include kinks, cracks, or any obstructions that could impede the flow of vapor. Additionally, verify the connections on either end to ensure a secure fit. Loose connections can also result in incorrect flow readings. If abnormalities are found, further testing may be required to determine if the tube must be repaired or replaced. Addressing any issues with Purge Tube B will help in ensuring the entire evap system functions effectively. Following the inspection of Purge Tube B, the next step is to perform a similar examination on Purge Tube D. This tube connects the evap canister purge nozzle to the intake air duct, playing a vital role in the proper functioning of the evap system. Begin with a visual inspection, checking for any signs of blockage, such as debris or foreign materials that could restrict vapor flow. Additionally, inspect the integrity of the tube for any cracks or other types of damage that may affect its performance. Ensure that both ends of the tube are securely connected. Loose connections can lead to vacuum leaks, resulting in incorrect purge flow readings. If any issues arise during this inspection, corrective actions should be taken, whether they involve cleaning, repairing, or replacing the tube. In this troubleshooting step, focus on the intercooler outlet pipe B, which is another critical pathway for the vapor flow in the evap system. Ensure that the Purge Tube D is disconnected during this inspection. Look for any debris, clogs, or obstructions in the outlet pipe that may interfere with the passage of vapor. This inspection is crucial, as blockages here can severely disrupt the intended function of the evap system and cause incorrect sensor readings, resulting in the DTC being triggered. Ensure that the pipe is clean and free of any physical obstructions. If any issues are detected, they must be rectified promptly to ensure optimal airflow and compliance with emission standards. The penultimate step involves checking the evap canister purge nozzle, an essential component for controlling vapor flow from the canister to the engine. Begin with a preparation step ensuring Purge Tube B is disconnected from the nozzle for effective inspection. Look for any signs of blockage, such as debris or contaminants that may prevent vapor from flowing as designed. If clogs are found, they can significantly impair the performance of the evap system, leading to failed emissions tests or decreased engine efficiency. Consider cleaning the nozzle if it is merely clogged, or if it appears damaged, replacement may be necessary to restore proper function. Maintaining this component is essential for the overall functionality of the evap system. In the final diagnostic step, analyze all results acquired from the previous inspections. If all other components performed normally, the focus should shift to the evap canister purge nozzle itself. Should all its inspections reveal no issues, yet the DTC persists, it is likely that the nozzle may still be at fault. A malfunctioning nozzle can show normal operational signs, but may fail under dynamic conditions. It is crucial to replace the nozzle if it is deemed the cause of the fault, as this will directly rectify the incorrect purge flow issue and clear the DTC from the system. Document all findings and replacements made, as they will aid in future troubleshooting and maintenance activities. Upon completing the necessary repairs or replacements related to DTC P04F0, it is essential to verify that the repairs were successful. Start by clearing the Diagnostic Trouble Code from the Powertrain Control Module (PCM) using the HDS. Following this, perform a test drive to ensure that everything is functioning smoothly, paying special attention to any signs of performance issues or emissions-related irregularities. Monitor the ECU, ensuring that no new DTCs appear during or after the test drive. If the system functions as intended and the check engine light does not come back, the repair is confirmed successful. Effective verification is crucial to maintain vehicle performance and compliance with emission regulations. To prevent future occurrences of DTC P04F0, performing regular maintenance on the EVAP system components is critical. Schedule routine inspections of the EVAP canister, purge valve, and associated hoses to ensure they remain free from blockages and in proper working condition. Additionally, ensure that any software updates for the vehicle's PCM are applied promptly, as these updates may include important fixes affecting the performance of the EVAP system. Ensure proper sealing of connections and immediate attention to any warning lights or symptoms can also help maintain the integrity of the EVAP system. By establishing preventive practices, you can decrease the likelihood of recurring issues and enhance the vehicle's emission system reliability. In conclusion, DTC P04F0 signifies an issue within the EVAP system, particularly regarding incorrect purge flow. Effective troubleshooting involves a systematic assessment of key components, including the Evaporative Emission Control System, EVAP, canister purge valve, various purge tubes, and associated nozzles. Symptoms like the check engine light, poor performance, and higher emissions rates underline the importance of addressing this issue promptly. Clearance of the DTC following repair is vital for ensuring vehicle compliance with emission standards. Finally, ongoing preventive maintenance is essential to safeguard the system against future faults and promote optimal vehicle performance. Understanding and addressing DTCs like P04F0 ensures a healthier vehicle, better compliance with emission standards, and enhanced driving experience. Please like and subscribe to the channel. See you next time!